Hey there, welcome back to the channel. In today's video, we will be focusing on like fixing some bugs that I've found. So, let's get into it. So, what was it? 192.168. Let me check. Then this is a bad start, but that's fine. 166, 139. So we will go into BFQ. Yeah, also I changed some stuff. So if you look at this, there's a new SPSCQ, there's a new JIGTOP is deleted. There's a reason to that. Makefile has been changed and BFQ has been changed. Let me just remove the extra thing, which is this one. Oh, I should have done it. Yeah, okay, fine. So it's gone, and then what was the another change that I did? Yeah, the top was deleted. Yeah, that's fine. Makefile has been changed. Yeah, there are a lot of changes in Makefile. But let me just show you what changes I did. I don't think there is much change, like, except for one where I've removed mod, like mod operation. Yes, that is it. Wait, I removed the line as. Yeah, okay. All right, yeah. Okay, tease head crash. Yeah, okay. Relax. Yeah. So this is correct. So since fill is mostly used by try push and try in place. So it's used by producer, right? So if it's being used by producers, then the producer core will have access to the latest edge too. So it doesn't need acquire on that. So we can just instead use it relax. That's the change I did. And sites should not do a mod operation. So I removed that. This was causing slowness actually. I'm not sure why. Maybe it's made for like bigger paths. So like this is quite short one. Like this is a simple instruction, maybe it can fit in. So maybe it's causing slowness. Yeah. So the simple emplace that we used to have is no longer present. Push will instead be calling emplace, and emplace will be taking two types of values. First is a R value, and then there's a reference. R value reference and L value reference. Um, R value reference, yep, yep, cool. And then this, yep, cool. Also, one other thing that I've found, which is actually causing my BFQ to be faster than the real top. Let me show you. So should I align this? Yeah, okay. Let's align that. So we go over here. Yeah. Let's just make it as it was, so we don't have a lot of changes. Yeah. One thing if you check is that you're directly popping stuff. Well, you can say that we can instead tell the user like you should be responsible for checking like what is the perform like if there are elements present in a empty thing, right? So that's what I think I did not explain that clearly. So what I was saying is that what Rectop does in its pop is it first checks if it's empty, and if it is not, then and then only it pops. So instead of putting the responsibility of checking if a queue is empty onto the user, it's doing it itself, right? And that's what Redtop does. So I should I should copy that too. So DQ first item of queue. You must ensure that the queue is non-empty before calling. So Redtop does it, so I have to do it too. This means that front must be called must have returned a null pointer before each call to pop. Mm. Before each call to pop requires this. Before each call to pop. Record stood is throw no destructibility value equal to equal. I still don't understand what this is, but maybe we'll recover that later. So let's add the condition. So if front, I don't need to call into front, right? Front is a simple thing. I need to take an input though. So if so, here's my front. Yeah, it returns a pointer. So if front is not equal to null pointer, okay. So this is cool. There's a extra if condition, but yep, it's fine. This should reduce performance by a lot. Maybe there's an extra if condition, but there's no else, so there's no branching, and then we'll check. So I need to do make run. Yeah. So what make run does is that it will also clone the SPSEQ. So if you wanted to try that, it will do it and it will compile the SPSEQ real one. So we don't have a rectop executable with us. It will run both of them. So we have SPSEQ. What is this? 105,000 operations, and this is twice of that. And our latency is lower. Let me run that again. Yeah. But I personally think that this is because of some error. That like there is something that is not going correct, which is the reason uh, something is happening. That's what basically something is not correct. Um, what could be the thing though? We can make this const explode because it's not a changing function, right? Okay. So my latency is low. Uh, not really sure why. So how about this? How about we go on little adventure? So make clean, and then we go for make debug, and then we do our thing. So perf that debug VFU. That's a bit. So debug BFQ does. Let's do it for support stat. What was this? SPSCP. Then the top. Right? Uh, is it inside? Oh, it might be inside of SRC and then the top. No? What? Oh, is it because we cleaned it? I need to compare the. Wait, okay. So make file was generated using num. What am I doing? But I understand what it's doing. This is basic stuff. Also, you can see this flag LP thread. Yep, I think it's like we weren't doing it, and it is important. I did not quite read completely like what I was doing, but okay. So, uh, so I was looking for debug. So debug VFQ is over here. Benchmark dash o dash LP thread. It isn't doing much, so it's just using CXX debug flags, which is G++ dash G stood equal to 20. Cool. So let's try that. So if you go in need to have a clue. Okay. Okay. Should I actually make changes in the make file itself? I'll remove these comments because I don't personally like them. I understand stuff. Um, okay, so debug PF, we have debug PF with us. Let's create a debug rig top. How about that? So I'll do it like this. So dollar debug rig top. So in debug rig top, what does it ask for? It checks that rig top directory slash src slash spsc q benchmark .cpp is present. Oh no, we don't need to do that. Okay, I'm sorry. Benchmark.cpp is present, and then it should also check that bfq.h. Um, if it is present, it's not really a thing, right? Maybe we don't need to add conditions like this. This stuff should be present. Maybe just a top dir is cool, you know. Hmm. Okay, so we can add our commands like dollar cxx dollar c not c what is that cxs debug flags. Yeah. So everything is similar to the above thing. So debug flags dash o should be so at the rate a is actually this one, I think, the left hand side. That's right, right? I forgot dollar at the rate a file as an automatically represents the name of the target. It represents the name of the being executed. So debug PFQ is what I said. Debug PFQ. Yeah. And then we'll add another thing which is debug red top, debug red top. It's the same length. Done. So dash o dollar date a dollar. This one is it's the first element on the right side, right? I think that is it. No, I'm asking for the is the name of the target being generated and the first prerequisite, usually a source file. Okay, so this is the first requisite, which is benchmark.cpp. So that's what they want. Dash O is given, and the benchmark.cpp is present in the top directory. I should type this SRC SPSC Q benchmark.cpp. So I can just do this. Okay, so this, and then AP thread will do it. And we will add another thing. When we do debug, this happens, and then also debug. Also, this one is required here. Right top. Yep. So this should work. Maybe, maybe not. We never know. So make link, make debug. Let's see if it works. And it doesn't. Fatal. Right top is basically .h, no such file or directory. it didn't find Riptop as PSQ. And that's right, it won't, because I did not add influence to it. So if we go over here, Riptop bench, and in case of Riptop debug PFQ, it just does this. Debug flags, benchmark, PFQ.h, it requires PFQ.h. And if we need to create this, let's say top PFQ dash o dollar added a, this, and then slash. So as to like create a, it's a better way to do it. Top directory, boom, 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 boom. So this should work, maybe. I think it will maybe. Oh, okay, so it compiled. So we have bench debug BSQ and we have debug top. So let's see. So let's go for perf stat debug BSQ. Oh, wait, didn't create. Oh, nice. Debug BSQ, and then we have. Should we run that again? Let's see. Perf stat debug BSQ. Okay, and now we'll do perf stat debug vector. We'll do it again and analyze the differences. Hmm. So, um, our vector, so BFQ took, okay, task block is on seconds, right? Okay, yeah, forget it. So page falls 260. Let's copy it. It's easier to do that way. And then something, then do this one to okay, GG's, boom, 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 boom. Okay, so let's read it. So time taken, 260 page falls. Is it a good thing or bad thing? It's a bad thing, right? Page falls. Okay. Instructions 31 million. What is this? 31 billion instructions. Okay. 1.60 instruction per cycle. Uh, 19 billion cycles. 18. 4581 branches. Lesser branches. Lesser branch. Oh, this one has lesser branch misses. Okay. I can see the cache misses. Is it present in, is it not given by this something? So if I run perf record debug here, what won't work, using the slash perf report So front is the main culprit again, and where do we see the this is edge? So sort, filter, verbose. So switch to another data, run scripts, this. Oh, so wait, what? Zoom into current processor socket. What does that do? This specifically zoom into current this one public percentage expand 98% expand collection called change. Okay, let's try this one. Zoom into current processor. I don't know what that is, but we are going to try. Oh, nothing happened. That's okay. Um, yeah, it's the waiting. Waiting is the thing that's taking a long time. 2.59, 7.14, that's cool. Q, clean, we'll do that. Yeah, okay. Let's clean, and then raw data. Clean doesn't have. Clean should also do debug PSQ and debug return. The side of the so debug the top, you know, ls clean, ls install, the git status, git diff, git file. Yep, a lot of things have changed. Ls git diff, bfq.h. Okay, a lot of things have changed. Yeah, actually, we don't need this function as const to explorer, right? Because it's not going to be const to explorer. So let's try it. Let's do it. So maybe there's bfq.h. No, don't. Done. This is necessary. This is necessary. How about we do one thing at a time? So let's keep the change of like wait, which one? So, yeah, okay. Let's keep the change for push, pop, push and place. Let's remove the changes for front size and fill. Yeah, front size and fill. So front size and fill. Now let's remove the one. So front. What is the change over here? Yeah, right over here. So change for this one is add capacity minus one, and here we going to add one. So this should remove some stuff, and most of the things are gone. We also need to add unlikely over here, and also restore pop. Okay, so we've done this, and we're going to restore. Oh, H. So, okay, so it's working. The only changes are void and push and embrace. So, okay, so we'll add, so this one, so this one, yeah. We hit add. You added another repository inside your, yeah. Okay, so let's remove that. So, um, maybe we can create a get alert file. Basically, does it's directly recognized enough? Mm, yeah, let's create a dot get and add if space in that. And so get status file specifically paper of restore. Okay. And slash any. I have a dot and keep it node and add directly dot get node. How can I ignore directly support as input using my sysctl on the user? Create a dot node. Oh, we need to add a slash after it. It's a slash after it. Okay. So and then dot get node, add a slash after it. So that will put add get status. So cool. That's basically what I've added. There's a new targeted node. There's a dash changes on whatever this is modified and then deleted. Okay. So get committed. So our changes were um, what should we call it? Is it called method overloading? Changes, or should I just say changes to push and embrace? I don't like this, but yeah, already up to date. Yep. Also, let's remove the branch. So git push dash d. What's it called? Uh, push deletion of a branch to the node. So that how to delete a branch locally on remotely. Git push dash d delete remove delete local. So git push dash d permission is always set. So I just need to write 10. Doesn't make sense without any references. Oh, okay. So I need to mention that. Version 10. Okay, so it's done. And then git push, not git push, but git branch dash d. Git branch dash d 10. The branch type is not fully merged. We are sure you want to merge it from git branch dash d. Yeah, git branch dash d 10. Git status branch. Okay, so if I go to my repo, Sure, then we we shouldn't be, we can't, yeah, there are no temp branches anymore. That's good. Choose a person, choose Batman. Oh, okay. Hmm. There's only one contributor, and that's me. Okay, let's get that. So, what are some other changes? 30 minutes in. Okay, cool. Not bad. So, DFQ Raj. So, let me tell you, like, what is the thing that's bothering me, right? So, what is bothering me is that, look at this. This is twice the number of operations that we have, that my code is doing as compared to SPSCQ, right? So, something is happening, something fuck is happening. And what might be the reason? Um, just a minute. So, hey there, back again. So, yeah, let's get right back into it. Uh, oh, my OBS has moved. Yep. So, this should be okay. Yep. So, what are the changes that we need to do? Yep. So, in BFQ, let's put in the changes that we were supposed to do. Like that was supposed to go. So, unlikely, right? Let me benchmark it. How about that? So, let me show you. So, our front code currently has unlikely, right? So, if I run make run, let's take average of 5. So latency 224, let me do it. So calculator. So 224 plus 240 plus 196 plus 245 plus 331 divided by 5, and it's 227 nanoseconds. And if we remove unlikely from it, from the statement, so unlikely, like, if we remove this, we clean, yeah, yeah, make run. So this is 267. Okay, off to a bad start. 215, 197, 201, and 232, which leaves us at 222. Okay, that might be a margin of error, but I'm not keeping the unlikely keyword anymore. Uh, so unlikely. Let me check like how bad is it unlikely. Decreases performance. C++. Hmm. Let's check. Does excessive use of likely unlikely daily? Yep, okay. The excessive use of likely unlikely daily degrade program performance is C++. I'm trying to understand what excessive usage really means in practice. If the user use is liable to result in performance degradation. Example one over here is this. Example two is over here. Spanner equal to 6. It is unlikely to happen. And okay, unlikely to happen, likely to happen. What does the standard mean by excessive usage? Can frequent use of likely and unlikely actually make code slow? Hash fun is excessive if that it only happens once during the program startup and it's not going to affect performance one bit. Okay, so if you have to use one word, then it's unlikely. The first question is that is what do unlikely and likely do for public products like GCC or Clang? A common misconception is that they influence the CPU branch predictor. This is not what they do, at least not directly. These hints tell the compiler that some block of code is more likely to execute, with understanding that the internal use of information has something to do with performance. So, a compiler may, for example, treat unlikely code as code and not optimize it as much. Example, don't bother using SIMD, don't inline as aggressively, prefer small code. Okay. Treat likely switch statements as the first to check. Treat likely switch statements as the first to check if a switch is going to be emitted as an if-else chain. Okay, reorder if-else such that the likely or at least not unlikely instructions are emitted immediately after the branch. This may include instruction cache hit or raise memory bus traffic if the instructions being executed in the virtual memory. Okay. So fewer taken branches in the machine code is also better for the front end since even a correctly predicted branch means the later parts of the 16-byte or 50-byte machine code fetch the cycle is unuseful. This is now the benefit of using other functions to go from case fast path through it is a straight line. Okay. Since the hints do not emit any specific extra instructions, there is no direct relationship between excessive use of burst times. If you mark up everything in a program as likely, it may perform exactly the same as before. What can make performance worse is giving poor hints, and that is likely to happen if you misunderstood what the hints do. Example for thinking they prime the branch predictor with better guesses or safe space in the branch prediction station by avoiding predictions and matches at all. About your examples with throw exceptions, your compiler might already treat code paths which throw as likely. Check it using call code. Okay. Macros will explain your work and what is the benefit. Let's for example, the difference in output, difference with GCC 4.8, this, built in except with the same effect as you would use attributes. Those of that make code slower than output. These just telling the compiler just practical part of make G code straight doing conversion to C. That can only find it to the badge of the similar creating along with the it's really necessary. I don't understand what C move is exactly, but okay. I think this is out of my syllabus for now. But okay. Can improve branch selection with my code because not taking branch costs. This is something that is super. Yeah. Wait, what were they talking about? Oh no. This is what they talk about. Yeah, this one is the interesting. We just faster and try run this code, and if I change behavior, if I compile it, if I compile this code with OC optimization flag, it takes 2.9 seconds, and this, okay, here's our code. Maybe I should try with O2, right? Let's try that. Just in case. Sorry. So I have O3 with me. Let's try it, just in case, not saying anything, just saying. Okay, 243, 294, 261, 241, 234. That is plain and simple bad. Yeah. But if I were to go back again and add a O3 flag, plain, so no, plain, fine, 230, 239, 226, 234, and 199. That is plain and simple. Good. GG's. Yeah. Okay. So I have some idea of what that means. So sometimes ability is bad, but sometimes it's good. Okay. Lucky times. So 226, right now, all latency is often higher than SPST, but we'll fix that eventually, right? Nothing bad. So, what was the other thing that we were talking about? So, removing this extra capacity minus one. Status. Okay, no. So status. That's another thing. So, is there anything that I left? There was something else. Um, yeah. Okay. Git add, git commit, remove extra modification size, and remove unlikely front location, and removed unlikely from front due to it being slightly slow. Push. Yep, cool. So we go to VFQ again. Yeah, let's change the field one. So we have to check if it's filled or not, and who does that? It's employees. Well, check. It's the producers that check while trying to fill stuff, right? So we add a relax over here. Yep, cool. And in the empty, so who's checking the empty? If you notice, who's checking the empty? Huh? Oh, also, yep. So employees should check if it is, if you're trying to employees into already filled an array, like it should be filled. That's what I mean. Yep. Uh, Also, pop should check if it is try employees and employees. Wait, employees are blocking algorithms, right? They will try to add stuff, right? Yeah, okay. We'll add the check in pop. Pop is used by consumer, and consumer has access to tail, so we don't need acquirement tail. It can be relaxed. In pop operation, we go over here and then add a check like if not empty. And if it is empty, then what should we do if it's empty? Should we not do anything? Hmm? Maybe not. Or is it blocking? Okay. So pop was is not very destructible. Let's check what pop does. In the case of the top, pop. It is a pop deactivates. Cool. Um, Reindex, relaxed, assert, yep, cool. Slots, this, destructive, deadductives, extract of whatever that is. That's not where it is. Okay, with this, dot, and then arrow. Next, read index is equal to read index plus 1. If next is equal to the capacity, then it's equal to 0. And then do a store. Read, read index dot store is a mix next to index. Okay. Then there's the next thing. I need to check like how empty is checked. So return depth of load is equal to depth of load. Okay. But there's value to okay. So when user asks for a constructor to be allocate extra space to capacity, allocator, capacity plus 2 times key padding. Capacity is reversed. So that's why we need to add key padding. If we add a padding, yeah, okay. So if we add padding, our empty check can be a lot easier than it is right now, right? Hmm. Okay. So I think this is done. It's fine. Place is okay. I need to add check like is it filled or not. So yeah. So if not filled, This is going to drastically reduce performance, but let's check. How bad is it? Um, on 69. Here's the size, return stuff. Okay, get diff, increase exchange, anti exchange, further exchange, and this clean, make one. No, run. Okay, it's bad. It's really bad. Oh my god. Okay, okay, it's bad. Yeah. Oh god. Maybe we can optimize it. It's so bad. It's so bad. Okay. Uh, so I guess that is it for this video. I guess we are ending on a note that our queue has suddenly become slower, a lot slower. Let's do it 5 times and take the average and I'll put that in the thumbnail. How about that? Okay. 1, 2, 3. This is the fourth time. And this is fifth time. So let's take the average. So on average, 282, 196. Okay. It's 282, 196. Divide by 196, of course. Oh my god, 43. Okay. 43. I should write this down somewhere. So 533. 43 plus 194, 277. So 4, 42.7. Let's take 42. And let's take for the decimals too, because 42.5. So this one is done. 195 and 273. 195, 195. That's 40%. Exactly 40. So this is okay. And then 270 and 196. 270, 196, 196, 37.7, 7 plus 281 minus 194. Here we have 194. 44.8. 5, 41.73, 41.74, let's take it 42. So my queue is suddenly 42% slower than TikTok. Okay, so that's what this is like a setup for the next video. And like suddenly our protagonist has hit a bottleneck, the the antagonist is beating him down and then we rise from the ashes. Okay, this is bad. Thanks for watching this video. I'm Aditya Bashani, and I am an engineer for fun. Bye.